Hi guys, let's look at the remaining questions of exercise 7D. Before we start, let's quickly revise what all we've done. Basically a revision exercise 7D which we've been doing. Let's revise the concepts of this chapter as such. So A is to B is equal to C is to D is a proportion. A into D will be equal to B into C. If I write it in the fraction form, that's A upon B is equal to C upon D. A and D are the extremes, B and C are the means. Next, continued proportion, which is three terms. So in continued proportion, A upon B is equal to B upon C, which would mean B square is equal to AC. In this case, B is the mean proportional, A is the first proportional, C is the third proportional. Next, we talked about certain properties of proportions. The first one, so if it is given that A upon B is equal to C upon D, then the first property we talked about was invertendo, which means invert everything, which is take reciprocal. So then if A upon B is equal to C upon D, then B upon A is equal to D upon C. That was invertendo. Next that we did was alternando, which means you substitute the numerator of one to the denominator of the other, or the denominator of one to the numerator of the other. So this becomes A upon C is equal to B upon D. This was alternando, which means alternate. Next, we did componendo, which was basically adding 1 to both sides, which is A plus B upon B is equal to C plus D upon D. This was componendo. Next, we did dividendo, which was A minus B upon B is equal to C minus D upon D. That was dividendo, which was we got by subtracting 1 from both sides. And in the end, if you apply componendo and dividendo together, we get A plus B upon A minus B is equal to C plus D upon C minus D. Perfect. So that's basically this chapter. Uh, let's go ahead and solve the remaining questions of this exercise. So the first question of this video is question number 21. It says using componendo and dividendo, find the value of x if what's given is there. Okay. So step 1, using componendo and dividendo, we get 3x plus 4 plus 3x minus 5 plus 3x plus 4 minus 3x minus 5. Everything is in the square root. That's the numerator. And in the denominator, I have 3x plus 4 plus 3x minus 5 minus 3x plus 4 plus 3x minus 5. Everything is in the square root sign. And on the right hand side, I have 9 plus 1 upon 9 minus 1. Yes, because the denominator of 9 is 1. This term and this term gets cancelled. First term and third term gets cancelled. So we have 2 times 3x plus 4 divided by 2 times 3x minus 5 is equal to 10 upon 8. Yes, 10 upon 8. That's 5 upon 4. 2 and 2 gets cancelled. Since we need to find the value of x, right now we have square root, which means we should square both sides. So squaring both sides, we get 3x plus 4 upon 3x minus 5 would be equal to 25 upon 16. Right, let's go ahead and solve it further, which means now we can cross multiply. Yeah, we can cross multiply. We are left with nothing now. Okay, so let's cross multiply. When I cross multiply, I get 25 into 3x, that's 75x, minus 25 into 5, that's 125, is equal to 16 into 3x, that's 48x, plus 16 into 4, that's 64. Let's bring like terms together. So 75x minus 48x is equal to 64 plus 125. 75 minus 48, that's 27. Yes, that's 27x is equal to 189. Right, that's correct, 189, which means x is equal to 189 upon 27. 27 1, 27 7, which means therefore x is equal to 7. Let's read the question. It says find x. We figured out x. X is equal to 7. Good. That brings me to the next question. The next question that we are doing is question number 22. Again, a question which appeared in your board exam in 2012. Using properties of proportion, we need to prove something. Okay, so first let's go ahead and use componendo and dividendo to remove some elements. What we have is x plus 1 upon x minus 1 will be equal to a plus 1 plus a minus 1 plus a plus 1 minus a minus 1. In the denominator, we will have a plus 1 plus a minus 1 minus a plus 1 plus a minus 1. Everything is in the square root sign. Fourth term and the second term, first term and the third term gets cancelled. So we have x plus 1 upon x minus 1 is equal to 2 times a plus 1 upon 2 times a minus 1. What I need to prove, I have x square, which means I will have to square both sides, plus here also I have a in the square root sign, so I will have to square it to remove the square root sign. So squaring both sides, we get x plus 1 whole square, which will be equal to x square plus 1 plus 2x. In the denominator, x square plus 1 minus 2x. And here this 2 and 2 in any case has got cancelled. So we have a plus 1 upon a minus 1. Again, I still have a lot of terms and many variables. So let's apply componendo and dividendo again. So applying componendo and dividendo, we get left hand side becomes x square plus 2x plus 1 plus x square minus 2x plus 1 divided by x square plus 2x plus 1 minus x square plus 2x minus 1. And on the right hand side, I get a plus 1 plus a minus 1 and a plus 1 minus a plus 1. So a and a gets cancelled, 1 and 1 gets cancelled. Here negative 2x and 2x gets cancelled, negative x square plus 1 minus 1. So the numerator now is 2 times x square plus 1. Denominator is 2 times 2x. 2 and 2 gets cancelled. Here we have 2a upon 2. 2 and 2 get cancelled. Let's cross multiply. Now what we have is x square plus 1 is equal to 2ax. Okay, that's exactly what they want. So let's bring 2ax on this side. So x square minus 2ax plus 1 is equal to 0. Hence, proof. That's exactly what they wanted us to prove. We've been able to do it using componendo and dividendo 2 times and squaring both sides. These are the three elements which we used. Let's go on and do the next question. The next question that we are doing is question number 24. It says if x upon a is equal to y by b is equal to z by c, show left hand side is equal to right hand side, up in a paper with question which appeared in your 2016 board paper. So let x by a is equal to y by b is equal to z by c is equal to k. Let that be the assumption. So x by a is equal to y by b is equal to z by c is equal to k. What this gives us is x is equal to ak, y is equal to bk, and z is equal to ck. Now let's substitute this in the left hand side and see what we get. So our left hand side becomes x cube, which is a cube k cube upon a cube, okay, plus y cube, which is bk whole cube, which means b cube k cube upon b cube. And the third term is z cube, which is c cube k cube upon c cube. So c cube and c cube gets cancelled, b cube and b cube get cancelled, a cube and a cube get cancelled. So our left hand side is equal to k cube plus k cube plus k cube, which means left hand side is equal to 3k cube. Let's see if we can prove right hand side also equal to 3k cube. Okay, let's look at right hand side. So our right hand side is 3xyz upon abc. So instead of x, I'll write ak Instead of y, I write bk. Instead of z, I write ck. This is divided by a, b, c. A and a gets cancelled, b and b gets cancelled, c and c gets cancelled. So what we have here is 3k cube. So right hand side is equal to 3k cube. So from 5 and 7 we get, therefore LHS is equal to RHS, hence proof. That's exactly what they wanted us to solve in this question. We've done it. Good. Let's look at the next question. The next question that we do is question number 26. Okay. This says if 7m plus 2n upon 7m minus 2n is equal to 5 by 3, we need to figure out the value of m is to n. Okay, so let's apply componendo and dividendo. So using componendo and dividendo, I get 7m plus 2n plus 7m minus 2n upon 7m plus 2n minus 7m plus 2n. On the right hand side, we have 5 plus 3 upon 5 minus 3. This gives me negative 2n plus 2n gets cancelled, negative 7m plus 7m gets cancelled. So we have 14m upon 4n is equal to 5 plus 3, 8, 5 minus 3, 2. Since we want the value, so this is 2, 1, 2, 4, this is 2, 2, 2, 7. Since we want the value of m upon n, let me write this as 7m upon 2n is equal to 4 upon 1, which means m upon n is equal to 2 into 4 upon 7, which is 8 upon 7. Now they want the answer in the ratio form, so we will have to write the answer in the ratio form, which is m is to n is equal to 8 is to 7. That's what they wanted. We've been able to figure that out. So this part of the question done. Again, now I notice if I had the value of m square upon n square, I should be able to get what is required by applying componendo and dividendo, which means let's figure out the value of m square upon n square. So m upon n is equal to 8 upon 7, which means squaring both sides, we get m square upon n square, 8 square, that's 64, 7 square, that's 49. Let's go ahead and apply componendo and dividendo. So using componendo and dividendo, I get m square plus n square upon m square minus n square is equal to 61 plus 49 upon 61 minus 49. So this gives us m square plus n square upon m square minus n square is equal to 61 plus 49, that's 100 and not 61, 64. My mistake, this is 64. I don't know why I wrote 61. This is 64. So 64 plus 49, that's 113. And 64 minus 49, that's 15. So the value of this is 113 by 15. Maybe we should write it in the mixed fraction. So this is 15 into 9 or 15 into 8 is 120. So 15 into 7, that's 105. 8 upon 15. Yes, 15 into 7, that's 70, 105 and 8. That's correct. So the value of m square plus n square upon m square minus n square is 7, 8 upon 15. Good. That brings me to the last question that I do with you from this chapter and this exercise, which is question 27, part 2. It says find x if 16 times something is equal to something. Okay. I notice that this is these terms here, a minus x, a plus x, and these terms here are exactly the same, except they are reciprocal of each other. So let me take this left hand side to the right hand side and see how does it work. So 16 times a minus x upon a plus x cube is equal to a plus x upon a minus x. That's given, which means 16 would be equal to a plus x upon a minus x divided by a minus x upon a plus x, the whole cube. This is division of fractions, which means we get a plus x upon a minus x multiplied with a plus x upon a minus x, the whole cube. That's equal to 16. Okay, this gives us 16 is equal to a plus x upon a minus x to the power 4. Yes, this is power 1, 3, this is power 1. You add the power since the bases are the same. So we get 16 is equal to something to the power 4. 16 can be written as 2 to the power 4, and this is equal to a plus x upon a minus x to the power 4. Taking the fourth root of both sides, we get 2 is equal to a plus x upon a minus x. Next, we could cross multiply, or we could do uh, componendo and dividendo. So let's do componendo and dividendo. We can also cross multiply. That's after you've done, or we haven't, after you've done this step, you could use componendo and dividendo because the question clearly doesn't say which method to use. So this will be 2 plus 1 upon 2 minus 1 will be equal to a plus x plus a minus x upon a plus x minus a plus x. A gets cancelled, x gets cancelled. So what we have is 3 upon 1 is equal to 2a upon 2x. A and a gets cancelled. We need to find the value of x, which means x would be equal to a upon 3. That's the value of x. Okay. Did I do something wrong? No, I think this is fine. Maybe we can also look at the value of this as a plus x would be plus minus 2, right? Because if we are taking the fourth root, negative 2 to the power 4 will also give me 16, and plus 2 to the power 4 will also give me 16, right? So we can have two values of a plus x and a minus x. I used only one. Let's try and use the second one. So this is when a plus x upon a minus x is equal to 2. Next, let's look at when a plus x upon a minus x is equal to negative 2. Let's see what we get. So what we have is negative 2 is equal to a plus x upon a minus x. This time, let's cross multiply. So that's negative 2a plus 2x is equal to a plus x, right? Negative 2a plus 2x is equal to a plus x. Let's bring x on one side, x on a on other. So 2x minus x is equal to a plus 2a. That's x is equal to 3a, which means we get two values of x. X is equal to 3a, or x is equal to a by 3. Perfect. That brings me to an end of this video. I have marked some homework questions. Thank you so much. Take care. Be safe. I'll see you with the next chapter. Bye bye.